New research from Georgia Tech will look at how a harsh environment of outer space is by sending experimental solar material up to the International Space Station. Here now with more on the project is Judd Reedy. He is the executive director of Georgia Tech's Space Research Institute. Judd, welcome back to the show.
Thank you for having me on again, Chesley. It's good to be back.
Yeah, space is a brutal place for any kind of material. What makes these solar cells strong enough to survive up there?
Yeah, it's a variety of different types of solar cells, many of which have never been to outer space, let alone used here terrestrially. The most exciting one for me is one that's called perovskite, which is a new type of photoabsorber that gets degraded here on Earth by moisture attack from humidity, as well as the oxygen attack. So a good bit of the research is encapsulating that. But in space, we don't really have to worry too much about moisture or oxygen attack. And so we think it'll perform pretty well.
Yeah. I understand you're testing about 18 different samples. How did you decide which ones make the cut?
Yeah, we probably made 20 to 30 total, tested them, and got the best of the best. I got some of the ones that didn't quite make it right here beside me, so you can see examples of what would be going up there.
What will they have to withstand? Now, you mentioned that you don't have to worry about a lot of moisture, don't have to worry about other things, but what made them stand out?
The perovskite is, we've known about perovskite since the 1800s, but didn't know it was a good solar cell until a couple decades ago. And the slope at which improvements have been going on is much, much faster than, say, a silicon cell, which are also some of the cells that we've got going to the space station. And so this shows so much promise for the future. Silicon is a very mature technology. And we've got silicon cells that we made at Georgia Tech also going. They're essentially our controls that we're comparing everything to. It's exciting. We've got 4 different research groups at Georgia Tech, as well as commercially provided solar cells that we're lofting up to the space station.
Yeah. What kind of results are you guys looking for, and how long will the cells stay up there?
They'll be up for about 6 months of external exposure, probably going up in October of this year. And the current voltage comparisons, it's called an IV curve, is what will be pulling the electrical data. We'll also have cameras that will look at them, and then we'll get the cells back themselves to study as well.
You mentioned how here in our atmosphere, how those cells will break down. Explain to us how they break down in outer space.
Outer space is harsh. So down here, we've got O2, oxygen that we're breathing. The ozone, which is higher in the atmosphere, is O3. In outer space, it's atomic oxygen, so that's O1. And that O doesn't like to be just O1. It very much wants to bind with something else. And often that's your spacecraft or your solar cells or your electronics or all sorts of things. So that degrades it. You also have to worry about micrometeorites, just tiniest flecks of dust traveling at incredibly fast speeds and parts energy that can destroy all sorts of penetrate through metal very easily.
Talk about how your research is going to help us out in the future here.
Well, the research that we do in space improves the solar cells here. For instance, perovskite, I mentioned that it degrades from moisture and oxygen attack. In space, we don't have to worry about that. Maybe we discover new degradation mechanisms in space that we don't know about yet here on the Earth because they're masked by the current degradation mechanisms. So it gives us a way to speed up the implementation of these technologies on Earth.
All right. Could we be talking about longer lasting satellites? Could we talk about solar farms maybe on the moon? Is that all a part of this as well?
Certainly longer lasting, cheaper, lighter weight, many benefits of going to space. Many of these thin film solar cells possess those qualities. And I certainly hope we have solar farms on the moon. The moon is challenging though, because it's dark for 2 weeks while it's bright for 2 weeks. So you got to have batteries when you're in the lunar night, which is 2 weeks of Earth nights.
Does research for you like this ever get old to you?
No, I wanted to be an astronaut when I grew up. So this is getting pretty close. If I can touch something that actually goes to outer space and then really touch it after it's come back from outer space, that's fun too.
Yeah. What else, is there anything else you could tell us that you guys are working on?
Oh yeah, the Space Research Institute at any moment has about a dozen different missions, either already in space, about to go to space, in the construction phase, planning phases. So yeah, I could fill up a next hour of your show if your producer will let me.
No, he's not going to let you do that, but we're going to have you back, of course, and we'll talk about those things. We're always interested in what's going on up there in outer space, and especially when we talk about what's up there, how long it's up there. Folks are really interested in that. So we'll have you back, and we'll have you talk about that.
Thank you, Chesley. Always
right.
good to be here.
Always good to see you, my friend. Take care.